Have you ever stirred Dettol into water and watched it spread like magic? Or caught the smell of your favorite food even before entering the kitchen? These everyday moments aren't just coincidence, they're proof that something incredible is happening all around us. They hint at a deeper truth hidden in plain sight. Matter is made up of tiny, active particles, and these particles have fascinating characteristics. Let's start with the first key characteristic of matter. Particles of matter have space between them. Imagine this: you take a glass of water and stir in a spoonful of sugar. Within seconds, the sugar disappears. But here's the surprising part: the water level doesn't rise. So, where did the sugar go? It didn't disappear. Its particles fit into the tiny, empty spaces between the water particles. This simple observation tells us that matter isn't packed like bricks. Instead, it has gaps between particles, even in a liquid like water. And these gaps allow other particles to move in, dissolve, and spread. Let's move on to the next fascinating trait: particles of matter are always moving. Think of this: when an incense stick is unlit, the smell barely travels. But once you light it, the fragrance spreads across the entire room. Why? Because the particles of aroma mix with the air particles, and both are constantly in motion. This motion is called kinetic energy, and guess what? It gets stronger with heat. Let's test it another way. Drop ink into two beakers, one with cold water and one with hot water. Which one spreads faster? The hot one. That's because heat gives particles more energy and they move faster. So, here's the takeaway: the higher the temperature, the faster the particles move, proving they're always in motion. Let's explore the third major characteristic of matter: particles of matter attract each other. Imagine a fun classroom game. 3 groups of students form chains. One group locks arms tightly, another holds hands, and the last just touches fingertips. Now, a 4th group tries to break those chains. Which one falls apart first? Of course, the one with just fingertips. This playful example mirrors how different materials behave in real life. Solids like iron, their particles hold on tight, that's why they're hard to break. Chalk, easier to break because the particles are less strongly held. Water, try slicing through it with your fingers, the surface resists you. That's intermolecular attraction at work. Different materials have different strengths of attraction between their particles, and this determines whether they're rigid, flexible, or fluid. Now, let's link everything we've learned to some real-life scenarios. Ready? Ever wondered why a diver can glide through water, but not through a wall? That's because water particles have weaker attraction and more space between them, unlike solids, where particles are tightly packed. Why does hot food smell stronger than cold food? Because heat boosts the motion of particles, allowing aroma particles to spread faster and reach your nose sooner. And how about a rubber band? It stretches but doesn't snap immediately. Why? Its particles have moderate attraction, strong enough to hold together, yet flexible enough to bend. Simple questions powered by particle science. Let's walk through a simple reasoning question, step by step. Question: if particles of matter attract each other, why does chalk break easily but an iron nail doesn't? Step 1. Identify the materials. Chalk is soft. Iron is hard. Step 2. Analyze the bonding. In chalk, the force of attraction between particles is weak. In iron, the particles are tightly bound by a much stronger force. Step 3. Conclude logically. The strength of attraction between particles determines how hard or soft a substance is. That's why chalk crumbles, but an iron nail doesn't budge. Before we wrap up, Let's take a quick look at what we've uncovered. First, particles of matter have space between them. Second, they're constantly in motion. And third, they attract each other. Simple, right? But these three characteristics explain so much: why solids are hard, why liquids flow, and why gases spread out to fill any space. And here's the exciting part: these very properties are the foundation of the three states of matter. So stay tuned, because that's exactly where we are headed next.